Okay, we're looking at the first year core textbook and we're on mixed exercise 7, question 11. So we've got an exam question. First bit's only worth 2 marks, so shouldn't be too bad. And although it doesn't actually say using factor theorem, that's what this question is. And you certainly do get exam questions where they specify to use factor theorem, and then you won't get the marks if you use any other method. So we're showing something is a factor. So if x minus 2 is the factor, I'm going to substitute x equals 2 into f of x. So I'm going to substitute 2 into this. So that is going to be 2 cubed plus 2 squared minus 5 times 2 minus 2. And I'm expecting that to equal 0. I'm just going to show an intermediate stage of working to confirm I have actually done this. So if f of 2 gives me 0, then x minus 2 is a factor. So that feels about right for 2 marks. By far and away the quickest way to do it. Okay, so hence or otherwise, so to be honest, hence is always going to be the way to go. So using this previous answer, find the exact solutions. Okay, so f of x is x cubed plus x squared minus 5x minus 2. And we have just shown that x minus 2 is a factor. So basically I want to find out what that missing quadratic is. So I'll do it by inspection first, and then we'll quickly run through it with the grid method. So first thing I'm going to think about is the x cubed term. And if I was expanding out these brackets on the right-hand side, I need x times that first term to equal x cubed. So that first term must be x squared. Okay, because that's going to give me my only x cubed term when I multiply those brackets out. If I use the same logic with the constant, so I need the constant to be minus 2. And when I expand these brackets out, the only constant is going to be minus 2 times the constant in the quadratic. So minus 2 times 1 is what would give me minus 2. So let's change that to black. So that's going to be a plus 1. So all I'm now missing is that middle term of the quadratic, so the x term in the quadratic. So I can get that from looking either at the x squared or at the 5x. So I'm going to look at the x squared, and then I'm going to use the minus 5x as a check. So if I were expanding out the brackets on the right-hand side, where would my x squared terms come from? Well, it would come from the minus 2 times the x squared, so minus 2x squared, and then the x times the missing x term there. And together, they need to give me x squared. So I'm going to need another 3x squared, because minus 2x squared plus 3x squared would give me x squared. So how am I going to get that? Well, that's going to come from x times 3x. Okay, so that is, I think, is the quickest way to factorize. We've not totally finished the question, so we need to check if that quadratic factorizes. I mentioned using the minus 5x as a check. So if I were to expand the brackets on the right-hand side out, where would my x terms come from? Well, minus 2x times 3x and x times 1. So they would give me an x term of minus 5x. Okay, if you're not happy doing it that way, you can use either the algebraic long division or the reverse grid method. So let's quickly whip through that. So reverse grid method, so that part of the grid will give me my x cubed. Those two will give me my x squared. That is going to give me, they will give me my x term. And that will be my constant. So and I'm dividing by x minus 2. So it's exactly the same kind of logic as we used here. It's just written out differently. So I need my x cubed term to be just x cubed. So that will need to be x squared. X squared times minus 2 will give me minus 2x squared. I need x squared, so I need to add 3x squared onto that. So that must come from x times 3x. Minus 2 times 3x gives me minus 6x. I want minus 5x, so I need to add 1x onto that. That's going to come from x times 1, and then 1 times minus 2 gives me minus 2. And that last bit is really just to check, because they should end up equaling the same thing because we know there's no remainder. So whichever method you use is absolutely fine. So whichever way we've done it, we've got f of x is x minus 2 times x squared plus 3x plus 1. Okay, and there's a bit of a clue in the wording of the question here. So normally, so if it said factorise fully, I would be looking to see if this quadratic factorises, and it doesn't, because it would have to be, both the constants would have to be plus 1, and there's no way of getting plus 3x. But it doesn't ask me for that. It asks for the exact solutions, and I do need to be a little bit careful. The way they've worded that question, you could put it straight into a calculator, but I think we need to assume that they'll find a way in the exam of not allowing that. So they'll say something like calculator methods are not acceptable. Well, so I've got one solution straight off. I've got x equals 2. So we're starting part B now. And then just because that doesn't factorise, be ever so careful, doesn't mean that it doesn't have solutions. In fact, if you did a quick check of the discriminant, b squared minus 4ac, it does have solutions. So got to rack your brains back to your quadratic formula. So minus b plus or minus the square root of b squared minus 4 times a times c. So 4 times 1 times 1, all over 2a. So x is minus 3 plus or minus the square root of 5 over 2. So that's, so as I said, your clue was the fact it said exact solutions. So as soon as it says exact solutions, we're expecting surds or something like that. Okay, so they would be so I've got 3 solutions there. Let's just double check. Minus 3 over 2 plus or minus root 5 over 2, and x is 2. Yep, we're good.